In section 9, we will look at polynomial addition and subtraction. The use of the calculator is allowed on this section. So when we're looking at the first polynomial, we want to start by writing it in standard form. The first term here is going to be negative x squared. We now are going to look for our linear term, and 3x and 2x here can be combined to give me 5x, and then finally we have our constant, which is going to be minus 6. So here's our standard form. Now based on that, we want to come up with the degree, the constant term, and the number of terms. So remember, the degree is based on the highest exponent throughout, and that's going to be 2 here. Our constant term is the one that does not include a variable. So in this case, that's negative 6. Number of terms here, we don't want to look at that until it's in standard form, and since it's in standard form here, I can count 1, 2, 3 terms, and that's our answer. So go ahead and look at examples 2 through 5 and complete those problems. So as we look at number 2, our highest degree here is 5. So as we combine these two, 1y to the 5th minus 3y to the 5th, I'm going to get negative 2y to the 5th. After that, I'm going to be looking for a degree of 4. And I only have one term that has a degree of 4, so I leave that as just positive 5y to the 4th. Then I would be looking for degrees of 3, 2, or 1, which I don't have any of those here. So then our last term is going to be just that minus 4. So our degree here, the highest degree within this expression is 5. Our constant term would be negative 4. And then the number of terms, again, once simplified, there's 1, 2, 3. In example 3, here our highest degree is 2. So we'll rewrite this 4p squared first. After that, I'm looking for a degree of 1 for my linear term. So again, that's going to be this negative 11p and positive 5p. Those will combine to give me negative 6p. From there, our degree is going to be the highest of any of the degrees in the expression, which in this case is 2. My constant term is going to be 0 in this case because I don't have anything that's listed that does not include a variable here, and so that's going to have to be 0. Number of terms here, again, we don't decide this until it's simplified, but there's 2 terms here. In number 4, with this one, again, our highest degree is 3. So I'm going to look at 7b to the 3rd and negative 4b to the 3rd and combine those to give me 3b to the 3rd. Next, I'm looking for my quadratic term, the squared term. And I only have one term, and that's 2b squared, so that's going to go next. After that, I'm looking for my linear term. Again, I just have one term that qualifies there, so I keep that as negative 3b. And then I just have one constant term, so that's positive 5. My degree, highest degree within this is 3. Constant, the term without a variable, is 5. And then for the number of terms, again, don't judge it until it's in standard form, but we have 1, 2, 3, 4. And then finally for question number 5, when I rewrite this, highest degree is 4, so I move that negative h to the 4th to the front. After that, I'm looking to the 3rd power. We don't have anything there. Then I'm looking to the 2nd power, so h squared is going to go next. Following that, I've got h and I've got 2h. When I combine those two, it's going to give me 3h. And then finally, when I'm looking for constants here, I just have a constant of 1. So here the degree is going to be 4. It's the highest of all of the degrees. Our constant term is just 1. And then for the number of terms, once simplified, we have 1, 2, 3, 4 terms. So in question number 1, we're going to answer 3 questions. Part A, what is the quadratic term? And remember that the term is not just the number in front, but the entire part here. So we're going to get negative x squared. Coefficient of the quadratic term, that's going to be the number that's in front of x squared, so that's going to be negative 1. And what is the linear term here? Linear meaning the term that has a degree of 1, and that'll be 5x. For question number 2, what is the quartic term? So we're going to be coming over to 5y to the 4th. The coefficient of the quartic term is the number in front, so that's going to be 5. And then what is the lead coefficient? Again, we don't decide what the lead coefficient is until it's in standard form, and then it's going to be the very first coefficient in the expression, and that's going to be negative 2. For number 3, the linear term, again, that's the one with the degree of 1, so that's going to be negative 6p. What is the coefficient of the linear term? Again, that's the number at the front of the term, and that's negative 6 here. The quadratic term is the squared term, and that's the whole thing, so that's going to be 4p squared. For number 4 then, the cubic term is going to be 3b to the 3rd. The coefficient of that term is 3. And then as far as the name of the term containing b, we're talking about this term right here, and that's going to be considered linear because it has a degree of 1. With example 5, the coefficient of the quartic term. So quartic term means we're going to the degree of 4. And here they're just looking for the coefficient. So that's the number in front, and that's going to be -1. What is the name of the term containing h squared? So h squared is going to tell us that that's the quadratic term. And then finally, what's the coefficient of h squared? Well, again, there's no number written in front of it, so we have to make the assumption that that's a 1. The directions here say that we're going to distribute where appropriate, we're going to combine like terms, and then we're going to rewrite the polynomial in standard form. So as we start with question number 6 here, I'm going to scan through and look for anything that I need to do. And the only thing that needs to happen here is I need to distribute this negative throughout the expression. So here when I do that, I leave this first expression alone for now, and I can just drop those parentheses because nothing is distributing in. Then when I distribute the negative into this one, I get -4x squared plus 6x plus 12. Now as I combine like terms, I've got 2x squared and -4x squared. Well, that's going to combine to give me -2x squared. Then I've got 3x and 6x, which will combine to give me 9x. And then finally -7 and +12, which is going to combine to give me 5. So this should be my final answer on number 6. For number 7, we're going to start by distributing the 5 into the first expression. And then with the second expression, there's nothing to distribute. So we're going to leave that one alone and drop the parentheses. Here I end up getting 20x squared minus 15x plus 10 plus, and again, I'm just rewriting this expression. So now as I start to combine, well, I want to scan through and see what the highest degree is here. Highest degree is 3, and there's nothing to combine that with, so we transfer 3x to the third to the front of the expression. This one's gone. Next, I'd be looking for a degree of 2. Now I have 20x squared, and I also have -2x squared. When I combine those two, I'm going to end up getting 18x squared. Next, I should be looking for a linear term. So here's -15x, and I don't have anything else here that has just an x or is a linear term. So that's just going to be -15x. And then last for my constant term, I've got 10 and 5. Those combine to give me +15. And then for number 8, here, the first part of the expression, we don't need to do anything other than just drop the parentheses. And then for the second part, we do need to distribute in a -6. So this is going to end up giving us this expression right here. Now as we go to combine things, 5 is going to be the highest degree throughout. So x to the 5th needs to go first. Next, I'm going to be looking for a quartic term, so that's a degree of 4. And I only have one term here that is quartic. So -42x to the 4th is going to go next. Next, I have x to the 3rd. So that's my cubic term. I'm looking at -7x to the 3rd as well as 36x to the 3rd. And when I do -7 plus 36, we should get 29x to the 3rd. From there, we're looking at quadratic. So I've got 4x squared with nothing to combine with. And so we'll leave that alone. Then I'm looking at my linear term. I've got -24x and nothing for it to combine with. So I'm going to leave that there. And then finally, when I'm looking at my constant term, I've got -6 and +48. Those two will combine to give me +42. And that's my final answer. In number 9, again, we're going to start by distributing the -3. And dropping the parentheses here because there's nothing to distribute. That's going to give me this. And then from there, when we go to write this in standard form, we want to look for the highest degree first. That highest degree is 4, and it doesn't have anything to combine with. So we rewrite that as -18x to the 4th. From there, I'm looking for a cubic term, and I only have one, so 3x to the 3rd goes next. From there, I'm looking for quadratic. I've got 6x squared and -5x squared. Those two will combine to give me just x squared. Next, I'm looking for linear terms. So -12x and +6x will combine to give me -6x. And then finally, my constant term, I only have one, and that's -8, and we write that last. And then for number 10, we're going to start by distributing the 4 in here and also distributing the -2 in here. And that's what we should get. From here, again, we scan through and look for our highest degree, which is going to be 4. So -4x to the 4th is going to go first. The next one I should be looking for is my cubic term, degree of 3. 12x to the third and negative 12x to the third. Those are exact opposites, so they will cancel each other out. So I no longer have a cubic term in my expression. Next, we look for our quadratic term or our squared term. Negative 20x squared and negative 20x squared will combine to give me negative 40x squared. Next, I'd be looking for a linear term, and we don't have a linear term here. And then finally, if I look for my constants, I've got 16 and negative 16, and those are exact opposites, so they're going to cancel, meaning that the final answer is just negative 4x to the fourth minus 40x squared. Now, when we look at some multivariable polynomials, we want to think about what can and cannot be combined. The variables and exponents need to be exactly the same. So when we're looking at this first example here, 6x squared y plus x squared y, we're examining the x squared y part, and since that part matches perfectly, what we would do is just add the 6, and then the lead coefficient here would be 1. So 6 plus 1 gives me 7, and again, I'm not changing the x squared y. The next one, I'd have x to the third z squared. And again, that perfectly matches up here. So if I do 8 plus 11, that gives me 19 x to the third z squared. And then for this one, I've got a squared b and a squared b. Since they match, I can just add those 9s together to give me 18 a squared b. Now for examples that cannot be combined, here I've got x squared y, and since this one is not x squared y, we cannot combine them. So that would be considered simplified since we can't combine. For the next one, I've got x to the third z squared. This is not x to the third z squared, so they cannot combine. And then here I have a squared, and since this is not just a squared, we cannot combine these. And something to keep in mind is that there is no standard form for multivariable polynomials. So if you have more than one variable in the expression, there isn't a standard form. In this course, when we provide answers, they will be given in order of the first variable exponent high to low, followed by the second variable exponent high to low. The constant term will always be last. When we're looking at degrees of multivariable polynomials, what we're going to do here is when we have a single term, what we do is add the exponents within the expression. So we'll notice here that there's no separation by addition or subtraction. So we're going to take this 2 and 1, add them together, and our degree there is 3. For my next example, again, no separation of addition or subtraction here, so I'm just going to add 3 and 2 together, and my degree would be 5. For this one, I've got 4 and 2, so the degree is going to be 6. And then finally for this one, my degrees would be 1 and 7, so that's a degree of 8. Now it's a little different here because here I have the sum or difference of terms. So when I'm looking at this first one, again, they cannot be combined. And what I'm going to do here is I'm going to assess what the degree of each of these monomials, the single term expression, would be. And then whichever one is the higher is going to be the degree of the entire polynomial. So 6x squared y, I would take a 2 and a 1, add those together, my degree there is 3. In my second part, I've got a 1 and a 3. My degree there would be 4. So between 3 and 4, the highest one is 4, and that's going to be the degree of that expression. For my next one, I'm going to have 3 and 2, so 5 for this part, and then 2 and 5, so 7 for this part. Again, I go for the higher of the 2, and that's going to be 7. For my next one, I've got 4 and 2, so 6, and 1 and 1, so 2. Again, the higher is the 6, so that's going to be my degree. Here I've got 6 and 7, which is 13, and then I've got 1 and 10, which is 11, and the higher number there is going to be 13. As we look at number 11, we are looking at a multivariable expression. So it says that we're going to distribute where appropriate. Well, we have no distributions happening here. Combine like terms. And when we look at this, again, there's not a proper way to write these as far as standard form is concerned. But since we're dealing with x and y here, I am going to start with x's first. And I want to start with the highest degree of the x's. And that's going to be x squared. So I'm going to look through this and find anything with an x squared in it that can combine, and it doesn't. So my first term is going to be negative 2x squared. Following that, I'm going to look at which terms just have an x in them, and that's going to be this negative 8x, and it has nothing to combine with. Next, I'm going to look at my negative 2xy and the positive 4xy, as I combine those two, I'm going to get positive 2xy. So next, if I look at my y squared terms, I've got negative 9y squared, and then y squared and negative y squared, these are exact opposites, so those are going to cancel. So my next term would be just negative y squared. And then after that, I might be looking for a term that just has y in it, or maybe just a constant, and we don't have anything. So our final answer is this. And here, when we're identifying the degree, again, I'm looking at the degree of each of these individual terms. This degree is 2. This degree is also 2 because I've had a 1 and a 1, so 2. This degree right here would be a 1, and then this degree right here would be 2. So the highest of any of those numbers was 2. For example 12, again, I'm going to look for my a squared first, and I have a squared b here and a squared b here. So those two are going to combine, and I should be getting 7a squared b. Now, beyond a squared, I'm next going to look at just a to the first. And I have two different situations that end up with an a to the first power in them. And that's going to be where I have ab. So I have 9ab and I have 12ab. Those two are going to combine. I also then have a term that has ab squared, and that 3ab squared does not have anything to combine with, so I'm going to go ahead and write that next. And then, as we talked about a second ago, I have this term where I've got 9ab and 12ab, and if I combine those two together, I'm going to get 21ab. Now again, you would get full credit no matter which order these terms were in, but again, make sure that the lead coefficients are correct and match up with mine. For the degree then, what we look at here is that this degree would be 3 because I've got 2 and 1. This degree would also be 3 because I've got 1 and 2. And then the final degree here would be 1 and 1, which is 2. So my highest degree throughout the whole thing was 3. In example 13, here I do have some distribution that I can do, so I'll distribute the 5 to the first set and the 2 to the second set. And that's going to give me this. Next, when I look for things that combine, I've got y and z in this problem. And so I'm going to start alphabetically with the y, and I'm going to look for the highest degree of y. And so that's going to be this 5y to the third z squared and the 2y to the third z squared. As I combine those two, I'm going to get 7y to the third z squared. So these two are out. Now, when I look beyond that, I'm going to next want to look at y squared. And there's only one term that includes a y squared in it, and that's going to be this negative 10y squared z to the third. So that goes next. After y squared, I'd be looking for y to the first. So again, no, 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 no. This one right here has y to the first. So that negative yz has nothing to combine with, so I write that next. And then finally, I end up with just the constants left. So a 5 and a negative 6 are going to combine together to give me negative 1. Now, when I look at the degree, each individual one is what we're looking at. So this term has a degree of 5. This one does 2. This one would have a degree of 2, and then that one would have a degree of 0. But again, the highest one up throughout the whole thing was 5, and so that becomes our degree. And then for 13, again, we're going to start by distributing. Here, distributing the 3, then distributing the negative 5, and we end up with this expression. From here, I've got x and y, so alphabetically, I'm going to start with the x's. So I'm looking for x squared, and this one has x squared y, and then I also have an x squared y right here. As I combine those, I'm going to get 12x squared y, so these two are out. From there, I'm next going to look for just an x. Now, I have just an x in this term, and this term, and that term, but those are not all the same. So I'm going to want to put the one where it's xy squared. That one can go next. And then finally, if I combine 3xy and 5xy, that's going to combine to give me 8xy. And then when I look at the degree here, I've got a degree of 3, a degree of 3, a degree of 2. So my highest degree here was the degree of 3. For 15, same thing. We're going to do some distributing. And that's what we should get. And then as we look for things to combine, we've got A and B here. Alphabetically, we're going to start with the A's, and I'm going to look for the highest power on A, and that would be A squared. But I have two different types here. I have A squared B squareds, and then I have A squared B. So the negative 3 A squared B squared, and then the positive 6 A squared B squared are going to combine to give me 3 A squared B squared. Next, I'm going to look at where I have A squared B, and that's going to be 3 A squared B, and negative 6a squared b. Those two will combine to give me negative 3a squared b. And then my last term is where I just have a to the first, and that's this negative 6ab. And it has nothing to combine with, so I'm just going to rewrite that. As far as degrees, I've got degree of 4, degree of 3, degree of 2. So my highest degree here is this first one, degree of 4, and that's going to be my answer. For 16, I do have some distribution that I can do here. When I complete that, I get this expression. And then from here, when I go to combine like terms, I'm going to start by thinking about my two variables are x and y. Alphabetically, x is going to come first. So I look for the highest power on x. I've got an x squared here, and I have an x squared here. And since they're both x squared y's, they can combine. So if I do 7 plus 4, I'm going to end up getting 11x squared y. After an x squared, I'm going to be looking for just an x. So it's not in the first one, the second one, but right here, 32xy, and that one can combine with negative 5xy. Those will combine to give me 27xy. And then my final term here is going to end up being from my y squared, so negative 24y squared and negative 5y squared. Those will combine to give me negative 29y squared. Last part, I look at the degree. The degree here is 3. The degree here is 2. The degree here is also 2. So the highest throughout the whole thing was a degree of 3. So please complete the exit slip that's associated with this lesson. And then for tonight's homework, you are going to complete section 9 in your practice set.